Okay, so let's see if we can use those geometric series formula now. So we've got a information here. We've got a sum, so it's definitely going to be geometric as well because we're multiplying by 3, look, to get each term. So let's start writing down information. U1 is 2. R is going to be 3, and it says first 12 terms, so N is going to be 12. Right, our formula, well, let's use this one. Sn equals U1, R to the N minus 1, all over R minus 1. Let's put the numbers in and see what happens. So we're going to have the sum is equal to 2 multiplied by 3 to the power of 12 minus 1, all divided by, well, 2, because 3 take away 1 is 2. Well, those are going to cancel out. So on our calculator, the sum is just going to be 3 to the 12 minus 1, and that will work out to be on a calculator 531,440. Done. That was easy. Let's try another one. Okay, this time we're going to find a formula for the sum of the first n terms. Okay, well, we'll start putting down what we know. Excuse me. Okay, we've got U1 is equal to 9. Can you see what the R value is? It is going to be negative a third. I know it's negative because we're oscillating, look. Okay, negative, positive, negative, positive. That's only going to happen when R is negative. Right, let's pop these numbers in. We're looking for a formula here, so we haven't got n. That's going to be as part of our formula. So the sum is going to be, well, U1 is 9, and then we're going to have negative a third to the power of n minus 1, all over negative a third minus 1, right? Does that make sense? Everyone happy with that? Now, I could have used the other formula for this one, and I think that might have been better because I wouldn't have a negative number on the bottom, but that doesn't matter. We can just still carry on exactly as we were before. Now, we might want to tidy this up a little bit. I mean, but let's just carry on and see if we can do some tidying. So let's keep the top as it is for a second, right? We've got minus a third to the n minus 1. Now, on that denominator, we're going to have minus 4 thirds. So we're dividing by negative 4 thirds, which is the timesing by 3 over negative 3 over 4. I'm going to use that little inverse trick to help us out here. So if I think about multiplying that by the 9, I'm going to get negative 27 over 4, and I'm going to have minus a third to the power of n minus 1 there. And I'm probably going to stop there. That's enough. That'll do. Our formula is there for us. Right. Let's carry on. Let's have a little think about how we can apply these in a few more challenging ways. So this one looks like an interesting one. We have got a geometric sequence. We've got U1 is 5. That's given to us. We've got R is 2. Now it's telling us that S of n is 635. So can we help and can we use that to work out the value of n? I'm sure we can. So let's write out the formula. Sn equals U1 R to the n minus 1 all over R minus 1. And let's put some numbers in. So 635 is equal to 5, and then we've got 2 to the n minus 1 all over 1, haven't we? Right? So let's just not even bother. Let's just leave it like that. 5 times 2 to the n minus 1. Okay, well, what can we do from there? Well, we can divide through by 5, I guess. Do you know what I would do? I can clearly see this is going to be a calculator question, right? So why not just jump straight in on the calculator here? My suggestion would be to type in y1 is equal to 5 times 2 to the n minus 1 and input that on a calculator using the y equals button. So we like graphing it. And then maybe we could say, well, okay, y2 is equal to 635. And then we could find the intersection point. and that would give us, that x coordinate would give us the value of n we're looking for, and that will come out at n is equal to 7. All right, so I prefer to use a few tricks like that. We could have divided by 5, then we could have added 1, but we would have still had to use either logarithms or a table, and I think at this stage we're not doing logarithms in this video. That's probably the best way of working out that question. Okay, so hopefully this has given you some ideas about how that formula could be applied. I'll leave you to do your